This is section 14.4, adding and subtracting radical expressions. Okay, so what we're going to do is we are going to use the radicals or the square roots like we were doing before, but now we're going to do some add and subtract with those. Okay, so a lot of this is not as complicated as it sounds, so these first ones are pretty actually straightforward. So here we've got 12 times the square root of 10 plus 15 times the square root of 10. What I do is I think of these square roots of 10 as just kind of like a variable. So if this isn't part of the problem, but if I kind of think of this as like 12x plus 15x, because I know whatever square root of 10 is here, it's going to be the same exact value here. I don't know what it is off the top of my head, but whatever it is here, it's going to be the same exact thing here. So if I think of those as just kind of like a variable, and I had 12x plus 15x, I know what I can do there is I can take my 12 and my 15 and add those together and get 27, and then my x just goes with it because I've got 12 of whatever the object is and 15 of whatever the object is, add those together and I've got 27 of that object. Same thing happens here, so if you think about that square root as just like a variable or something that just kind of goes along with it, you can take your 12 and your 15 and add those together and get the 27, and then just stick the square root of 10 with it. Okay, that is your answer. Okay, you don't have to go any further than that. You don't have to simplify that square root of 10 down because it can't go down any further. Okay, so if you've got the same square root or the same thing under your square roots and it's all the way simplified down there, all you've got to do is add your numbers together and stick that square root value with it. Okay, similar here, so all of these have square roots of 2 with them. We do have a subtract here we've got to pay attention to, but what you can do is you can just think about them as variables. So if I thought about it as a variable, I'd have like 3x minus 9x plus, and then if it's just square root of 2 by itself, that would just be like 1x or just 1 of whatever it is. So if I think about it, well, I could combine my positives here, 3x, and if you think about that like it's 1x, that would be 4x minus 9x, and then 4 minus 9 would be negative 5x. So thinking about it similarly here, this is a 3 times the square root of 2. This is like a 1 times the square root of 2, or just square root of 2. So together those make 4 times the square root of 2, right? Minus 9 square roots of 2. Well, 4 minus 9 is negative 5. So negative 5 square roots of 2. Okay, and square root of 2 cannot be simplified any further because that is an irrational number. Okay, so that would be it. Now it might get a little bit more complicated. So like here, so the lengths of the 3 sides of a triangle are 10 times the square root of 3 centimeters, 9 square roots of 3 centimeters, and 5 square roots of 5 centimeters. Find the exact perimeter of a triangle. Okay, so we've got a triangle here. Our sides are 10 times the square root of 3, 9 times the square root of 3, and 5 times the square root of 5. Perimeter means adding all of the sides together. So we're going to add together 10 times the square root of 3 plus 9 times the square root of 3 plus 5 times the square root of 5. Now how this one is different here is these two are being multiplied by the square root of 3. This last one here is being multiplied by the square root of 5. So those are like saying they're different variables. So if I, this isn't part of the problem here, but if I redid it up here, so like 10, maybe say my square root of 3 was x, say my 9 with that same square root of 3 would be x, and then this, since it's square root of 5 here, think of that maybe as like a different letter, like a y. We know we can combine these guys together and make 19x, but we have to keep the 5 separate of it because it's a different letter there. Same concept applies here. We can add these two guys together, so 10 plus the 9 is 19 square roots of 3, but you have to leave the plus 5 square roots of 5 separate because they don't have the same number under the square root. Now if they did, if they were all 3's there under the square root, then yeah, you could add them, but here they don't. So that's just your answer. You can't go any further than that. Okay, think about it like having variables with different letters there. Okay, same concept. Alright, now we get into a little bit more complicated stuff because these numbers under our square root actually can be reduced down. So now we've got to go back to the stuff that we did in the last lesson and actually break these down here. So I need to break down 48 and 75. So if I was going to break down 48, maybe I'd go 4 and 12. And then 4 would go down to 2 and 2. And 12 would go down to 2 and 6. So all those 2's are primes. 6 could go down to 2 and 3. So that would be all my primes. And then 75, maybe I should write that out. So 2 times the square root, instead of 48, I'm going to put 1, 2, 3, 4 2's. So 2 times 2 times 2 times 2 times 3, 1 3 in there, minus, might run out of room here, 3 times the square root of, and then my 75, I'm going to break down, let's go 3 and 25, and then 25 can go into 5 and 5. So there's only 3 prime numbers for that one, so we'd have 3 times 5 times 5. Okay, so then I do my kind of solving like I was doing in the last section. So I'm looking for my pairs here. So I got 2 and 2 there I can pair up, and this one's got a 5 I can pair up, or 2 5's I can pair up. So this would be 2 times the square root of those 2's together make 4. Those 2's together also make 4. And then I've got a loner 3 there, drop down, minus 3 times the square root of, my 5's can go together to make 25, so I've got a loner 3, 5 and 5 pair together to make 25. And then if I keep breaking that down, it'd be 2 times the square root of 4 times the square root of 4 times the square root of 3 minus 3 times the square root of 3 times the square root of 25. And then I know square root of 4 is going to come out to 2, so 2 out front, 2 for my square root of 4, another 2 for my square root of 4, and then my square root of 3, can't do anything with it, so just drop it. And then here, 3 I drop down, square root of 3 I drop down, and then square root of 25 comes out to be 5. And then I look to simplify a little bit, so do my multiplying. So 2 times 2 times 2 would be 8 square roots of 3 minus, and then here I'm going to put my 3 and my 5 together to make 15. So 3 times 5 is 15 square roots of 3. And then if I did 8 square roots of 3 minus 15 square roots of 3, well, 8 minus 15 is negative 7, and I can combine those together because now they both have square roots of 3 at the end. So negative 7 square roots of 3 would be my answer. Alright, let's try another one here. So this time, we've got 4 times the square root of 27 and 5 times the square root of 12. Okay, so 27, break down, 12 I'll break down. Let me show you a slightly faster way to do this. So in some cases, as you get a little bit better with this, what you can do is you can look to divide by perfect square numbers. So what I would do is I'd go, okay, 27. What perfect squares can that divide by? And I'd go down my perfect square list. I'd go, okay, 27 can divide by 4. Well, if I try that, 27 divided by 4 doesn't come out nice. So that doesn't work for my perfect square. My next perfect square is 9, so if I did 27 divided by 9, that does come out nice. So I can go 9 and 3, and instead of breaking 9 further into 3 and 3, what I can do, because I now know that that number 9 is a perfect square, I can just use that here and save me some steps. So I could go 4, and then instead of square root of 27, I'm going to not put in my 3, 3, and 3. Instead of these two 3's, I already know those pair together to be 9. So I'm going to skip a step, and I'm going to go 9 times 3. And the only reason I can skip that step there is because 9 is a perfect square. Okay, if it came out to be like I don't know, 3 and 6. 6 is not a perfect square, so like if this was 18, I couldn't break it into 3 and 6 because then it wouldn't be a perfect square. Now what I could do if I had 18 is I could break it into 2 and 9 because 9 would be a perfect square and it would come out nice just like this is here. But I don't want to distract you too much from what we're doing. Okay, same situation with 12. I go through my list of perfect squares and go, okay, the first one is 4. So if I take 12 and divide by 4, that comes out nicely. So I'll have 4 times 3, and again, you could take and break 4 into 2 and 2, but we don't necessarily have to because we already know that that 4 is a perfect square, so I can skip some steps here and go minus 5, and then instead of 2, 2, and 3, I'm going to pre-combine together my 2 and 2, make them 4 already, times 3. Okay, and if that's confusing to you, don't do that. Break it all the way down to your 3, your 3, your 3, 3, 2, and 2, and do what we were doing on the previous problems. You don't have to do it this way if you don't feel comfortable, but it will save you time once you kind of get the hang of what's going on here. Okay, so then I can go into my breaking down here. So I can go 4, and then square root of 9 times the square root of 3, minus 5 square root of 4 times the square root of 3. And I know, since I kind of figured these out earlier and was looking for perfect squares, that these ones will come out nice. So really I've got 4 times square root of 9 is 3, times the square root of 3, minus 5 times square root of 4 comes out nice to be 2. Drop down my square root of 3. So 4 times 3 would be 12 square roots of 3, minus 5 times 2 would be 10 square roots of 3. So in the end, if I now do 12 square roots of 3 minus 10 square roots of 3, that's 2 square roots of 3. Okay, so that just saved us a little bit of time. Instead of writing all of those out and then combining them back together, we could look for perfect squares from the beginning and save us some time. And like I said, you don't have to do it that way, but it will save you in the long run. But if you don't feel comfortable jumping those steps, then don't. Do it like we did the other one. Okay, on page 621, try out F. So I'm on the wrong page here. So 621F, they got 36, 36 square roots of 2. And then our original problem, I'll do it out here for you since this is kind of some complicated stuff. So it is originally 7 square roots of 18 plus 3 square roots of 50. So what I would do is I would take 18 and 15, break them down. So 18 and 50. 18 looking for my perfect squares. The first perfect square that works for that is 9. So 9 and 2. So I'm going to go 7 times the square root of 9 times 2, and the reason I picked that is because 9 is a perfect square, so I could have went to 3 and 6, but neither of those are perfect squares, so then I would have to go the long way out. And then 50, my perfect square that pulls out of that is 2 and 25, so 25 in that case is my perfect square, so plus 3 times the square root of 2 times 25, and then doing this out here, I'd have 7 times the square root of 9, times the square root of 2, plus 3 times the square root of 2, square root of 25. So that would be 7 square root of 9 is 3 times the square root of 2, plus, and then 3 times the square root of 2, and then square root of 25 is 5. So this would be 7 times 3 is 21 square roots of 2. 3 and 5 is 15 square roots of 2. And then if I add those together, 21 and 15 would be 36 square roots of 2. So that's how they get to that answer there. So again, once you get the hang of it, I would go the quick way, but if that's too quick for you, don't do it that way. Go back to the previous way. Alright, so there's your book page assignment, page 622, 16 to 34 even, and 35.